Okay, splice-site mutation. So again, this is part of our effect of a substitution mutation and part of gene mutations. Okay, so remember when we spoke about transcription and translation and protein synthesis, gene expression, and we spoke about primary transcript and mature transcripts. And remember we had these sections of messenger RNA, this primary transcript of messenger RNA, and some of them were exons and introns. So exons were the coding sections of the messenger RNA and introns were the non-coding. And the whole point was that we went through a process of splicing, so RNA splicing, and what we did is we removed these non-coding sections, okay? So a splice-site mutation is when there's an issue with this process trying to remove the non-coding sections, okay? So again, it will come back down to the fact that there's been a change, a substitution mutation. So there's been a change in that nucleotide sequence, and what's happening is this is having an effect on these coding and non-coding sections. Okay, so splice-site mutations, a mutation occurring at a splice site. Okay, so during this process of RNA splicing, which results in an intron remaining attached to the messenger RNA. So remember, we go from having a primary transcript, and then once we know that we have our completed messenger RNA that is full of only coding sections, it therefore becomes the mature transcript that travels to the ribosome. However, what happens is that we end up retaining or keeping some of these non-coding sections within the mature transcript, okay? So here is our coding, non-coding, coding, non-coding, coding and non-coding, okay? But this is representing here that this non-coding section, this intron, is going to be bound onto this exon. So what should happen is we should go through this process of cutting out our non-coding sections, our introns, okay? But as we said before, this intron remains attached to this exon, this coding section. So that's read as a full coding section, okay? And then the cell splices these, what they presume is all exons, the coding sections, together. And this coding section is remains within this mature transcript, okay? And essentially, as it goes and travels to the ribosome, this non-coding section remains, okay? Because it's included in the mature transcript, which therefore gives us a faulty protein, because the protein we required only had these exons for that specific protein, but it now has a modified section to it, a non-coding section, so you will not end up with the protein that you are wanting, what the cell is looking for as such. Okay, so splice-site mutations is retaining these introns, these non-coding sections within the mature transcript.